workshop. I don't think that we sent out the pre-workshop setup anywhere, so we should probably go through that now. So your first steps are probably just going to be going to revel.it and signing up for an account or logging in with Google or one of their other providers, and then just creating a new REPL. Once everyone has done that or is ready, just drop an emoji in workshop chat, I guess. That's good. So then we're probably just going to need to add some packages. There should be this really nice cube icon, and what it'll do when you click on it, it'll have a pop-up in which you can search for requests and GeoPy. So I suppose drop another fish or react to your own message or something, I guess, when you're done that. Or if you have any problems, just let me know in workshop chat. If you weren't on REPL, you could just go, I assume, VS Code, I suppose. So you can basically just go in your terminal, run pip install request GeoPy, which will install the two necessary libraries, but otherwise everything will be the same. Alright, so we're gonna get into REST APIs and requests and do a bunch of really cool space things in this workshop. So today what we're going to do is learn how to use a REST API, or consume it if we're going to use fancy terminology, in Python. So Python is a really easy to learn programming language, and it's something that's pretty simple to get started with, so that's what we're going to be using. It will already be done in your replit if you created the Python one, which is good. And then what a REST API is basically, API stands for Application Programming Interface, and we use those to access information from the web. So the REST part isn't actually someone sleeping or other synonyms for REST. It's just a way of standardizing the design and what the API uses to communicate. Request is a Python library that we use to work with online APIs, and this workshop assumes a basic prior understanding of Python and that you've set up your replit, which you all have just done, which is good. But we'll be going through basic syntax in Python, I guess, so don't worry about that. And if you have any questions during the workshop, just drop them in workshop chat and I will check up on that. Alright, so our project is going to be using the Open Notify API to get information about the ISS. If you don't know what the ISS is, it's basically a large hunk of space metal that is currently orbiting the Earth somewhere. We will find out where it is in a little bit. So if you want to go to this website, you can just open that in another Chrome or browser tab. That's the main page of the website, which we're going to do something with shortly. With this API, we can basically get a lot of information, such as the current flyover location of the ISS, the next times that it will pass by our location, and the number of astronauts currently on board. But first we should probably talk about more in detail about what an API actually is. So what is an API? It's an application programming interface and returns information about a variety of different things. So for example, the one we're using right now is going to be to get ISS information. How to integrate Python script with standard website stack. Generally, you will have to run some sort of Flask server or some sort of server to host said REST API, and then get that information from like a standard website with JavaScript. But I will post, or if you scroll up in the workshop pins, I believe there's a workshop on Flask that I did a couple months ago, which does similar things, which you should also check out. I love this promotion. Alright, so back to the API stuff, I guess. It's used to build software and exchange blocks or information. Lots of social media platforms, businesses, and most of the web runs on APIs. For example, Instagram, Discord, Twitter, whatever TikTok. I'm pretty sure those all run on some sort of API. And how we get that information to consume is by making requests and getting responses. And then we can process that information for our own use, which we're going to do in just a little bit. Think of API as kind of like a big book that anyone can read. The ones that we'll be using today are ones that anyone can read. Other ones might have some authentication, but we don't have to worry about that at all. Alright, so let's finally get started with requests. So if you want to open up your Replit, you can copy that code in, just type it in. Just some basic things that end with one of the lines that end with one of those slashes. You don't need to type the slash. That just means that you should type the entire line on one line. The text box is a bit small for that, so that's why we've had to put the backslash. But ideally you would go page equals request.get opennotify.org on one line. And lines that begin with a hashtag, you don't have to copy. Those are just comments that are there so you can understand. Alright, so, we don't have to do that. So this should go in your main.py file, which is the default library that you should, or no, not library, the default file that you should have open anyway. Yep, the slides will be posted in PDF form in workshop pins right after and also it will be reposted on our YouTube, which you should subscribe and check out. Alright, so what this code does is first it imports the request library so we can use all the functions and fancy things that they've already done for us. What we do in the second line is we set the variable page to the contents of opennotify.org. We use the request.get function, which will return a response. If you see it, once we print it, you'll get like tag response 200, hopefully, if you're on the internet, which you have to be because you're on Discord. So what it should return is that response object. So as long as you have a 200, then everything is okay. And you should theoretically get a 200 once you run with the big run button on top of Replit. Once you've got that done, you can just, here, React. Yep, both slides will be posted. I'll link the one from Flask again, and then I'll repost these slides also. Alright, looks good. So let's talk a bit about requests and response codes, because those are kind of interesting. When we use that request.get function, we send a request to opennotify.org. This is basically Python going to request opennotify.org and being like, hi, I would like some information, thank you. That default request is going to be a GET request. We'll get more into types of requests later in a bit, which are like post and delete. I'll talk about that in a little bit. These requests can have things called headers and also things called bodies. So a header would be just meta information. For example, common headers are stuff like authorization if you're using an API that you have to have special access to. Linter says unexpected did you have to take out the backslash and make sure it just says page equals request.get. So once we've gotten our information back with our headers and a request, which is just a default empty request, no body. Oh, hello. And what it does is it gets a response from opennotify.org. So the first thing we just found was a 200 response code, which means that the response is all good and you have nothing to worry about, which is probably very good. So we want codes that start with 200. Anything else generally means that there is some sort of error. We especially do not want 400 or 500 codes. As long as we have that response 200, which is what you should have gotten, that's a Python response object with a code of 200. Now these response objects are stuff that Python doesn't come with automatically, but we got all of that information when we imported requests in the earlier slide. Alright, so let's get into some more fancy status codes and things. Alright, so the request.get returns a response. Now that response object has a status code member or variable that you can access to see what the status code actually was. Oh, hello. Oh, goodbye. So I've changed the link that you will be getting information from, which just goes to DNE, which does not exist as far as I know. And what you should get once you print the status code is a 404 error. As well, you can also access request URLs, request bodies, and request headers. From the last slide, we just talked about headers are generally meta information. Body is generally the information that specifies what you want to get or what you want to tell the server. So you can also print that information. And theoretically, you should get a response like something like http://opennotify.org DNE, none, because we didn't have a body, and then lots of headers that I did not include. Yeah. So once you've done that, yes, egg. Alright, so let's talk something about let's talk a little bit about JSON, which stands for JavaScript Object Notation. This is just a standard way of conveying information that a lot of web APIs tend to use because you can specify lots of variables in a very standard format. So this is just a key value store. If you're familiar with things like Python dictionaries, If you're familiar with things like Python dictionaries, it's a similar idea of a key value where, for example, in this object, working is a key and true is the value. Years old is a key and 22 is the value. So each line is separated by a comma, and these can give you booleans, which are true false, numbers, which are numbers, lists like this US, Russia, Canada, Japan, ESA, strings like International Space Station, and more. So let's get some JSON from our response. So if you can see here, we've changed the endpoint. So make sure that it says http://api.opennotify.org issnow.json, and make sure you take out those backslashes as well if you can get it all in one line. So endpoints, which are basically the URLs that we use, are configured on the server of the API, and we don't really have to worry too much about that. Usually when you look up web API documentation, you can get that all on their docs page, so you'll know which endpoint to use where. So here we're using the iss-now.json endpoint, and we're taking the response object and getting the JSON from it, which is that .json. And then we can print the page, which will return all of our information that we'll talk about on the next slide. And then we can also print our variables for the position of the latitude and longitude of our current ISS location. So .json turns all this response information into a Python dictionary, which is just another key value store type. And now we can access values like we would in a dictionary. Once you've gotten JSON, React here. Now let's use that GeoPy package that we downloaded at the very beginning of our workshop to get some proper information that we can actually read and is not complicated JSON. So The yellow highlighted lines are what we've changed, so you can just keep everything else the same. So we're going to be using GeoPy, which is a library to convert coordinates to the closest city to get the current position of the ISS. However, we should also know that if it prints none at this exact moment, the ISS is currently over water, which is very disappointing, I know, but I am not entirely sure where it is at the moment, so we'll find out when we get there. And if we go through the code, so this from geopy.geocoders import nominatim just imports the nominatim model, which is just something that reverses the geolocation. And then this locator variable, we set it to nominatim with a user agent of, say, VHHacks workshop 2. That can just be something random, but that's just to make sure that you're not spamming their requests. And then what we're going to do is get that location from the locator. So we're going to run the .reverse function, which we get from that nominatim object with the latitude and longitude that we got previously. Oh, and by the way, if you're not familiar with Python syntax, this f string is just putting the contents of the variable latitude into the string, followed by a comma, and then those brackets and longitude will put the longitude into that string also. Alright, so just again, the yellow lines indicate the concepts that have changed. So we're going to add a from time import sleep, which imports the default time module, which will give you a sleep function. And then we're also going to add a while true loop and then put a sleep right at the bottom for 10 seconds. So this will constantly check where the ISS is. However, for rate limiting purposes and to perhaps not spam their server with requests, try not to run the program for too long. And when you're done, just press Ctrl+C in the Replit terminal to exit, or in any other terminal to exit. Oops. Nominatim is basically a geolocation model that the GeoPy module imports for us so that we don't have to interface with other APIs, and it makes it a lot easier because we don't require any authentication. So it's just a pre-trained like reverser, so we can plug in, oh hey, we want location for XYZ latitude and longitude, and it'll just spit it right back to us. Once you're done with that, then oh, it looks like the ISS is going over water again. Oops. Oh well, I think it'll approach land. Oh, is it East Kenya? Oh. Oh no, at the moment it looks like it's over water. I'm looking at some astroviewer, but I think like it'll be approaching some landmass, which might well be Kenya. It also, the nominatim goes to the closest city, so perhaps we're at some fringe area where there is no city, which is also possible. Oh, we have got somewhere. Alright, sounds cool. So currently this is what you should get, minus the sparkles. Don't mind me, I had a bit too much fun making the printouts. So you should get this after you run main.py for a while. Obviously you'll have different areas, but this is what I had. Yes, sparkles. Alright, so let's also talk about query parameters. So to change the information that we receive from the API, we can use something called query parameters. It's also probably important to note that you can't do this on every API, but only if it's documented, or sometimes undocumented, but generally it will be documented, so check documentation. So query parameters go at the end of the request string, and they look something like this. So after the URL, you'll get a question mark, your parameter name equals parameter value. For example, to query for a person with a name of Charlie, we can use something like this, where you have the URL, question mark, name equals Charlie. So the API docs show us that we can find pastimes for a specific longitude and latitude. So we're going to be implementing this next. Alright, so what you can do now is either create a new Python file or copy your existing one, or just keep editing the existing one. But currently you might want to use something like latlong.net to find your current latitude and longitude. So we're probably gonna, I'm assuming you're starting from a new file, or that you're just gonna edit your new one or your old one, so you can delete the part with geopy. But what we're gonna do is take in a variable for latitude, which is going to be the input, and then we're also going to take in a longitude, which is going to be another input. So if you're not familiar with Python syntax, the input function is something that's right in the standard library, and basically what it does is it just takes input from the terminal window. So in Replit, that right hand side window, usually you can just type in it and then it will make a float out of whatever you put in. We're going to do a similar thing with the page, so again, remember to take out the backslashes, and also remember to change from ISSNow to ISSPass.json. And what we're going to do is add this parameters object for our method. So what it does is basically just takes in the parameters latitude and longitude, and then we put our longitude in with our longitude variable. Notice that we have quotes around the key and not the value, because we want our value to be what we have up here. And then just print the JSON out, and then we will get some very interesting information. Oh, I should also mention that you should take out the backslash in the middle of the parameters, but I think that should be good. Yes, the timestamp will be very long. I will get into that in, I think, the next slide. Yeah, so this is something that, yeah, I will be getting into the units in a little bit. So this is an example response for my location, which is somewhere in Vancouver. So we have to identify what we want and how to get it from this response, which is what we want is this rise time, which is in sparkles emoji Unix time, which is a different time measurement. Unix time is basically a count of every single second that has existed since January 1st, 1970. Which I think was just an arbitrary date that the computer science people just decided on. But basically that giant number that I will not try to say out loud is in Unix time, which is why it's so big, but it's also kind of precise. Alright, so how can we get that? So we're going to go from the top and add from time, import ctime. And then all the code which is getting the longitude and latitude will be the same. But then we're also going to add a new variable for the page responses, which, as you can see, is all of this information in the list, like the durations and the rise times. And then we're just going to loop over all the items in the response. So if you're not familiar with Python syntax, it's for response in, well, it's just for variable in other variable. And then what we're going to do is just translate the time into local time from the Unix time, and which is why we use a library, because it gets a bit complicated to do. But what we're just going to do is take the rise time of each result. Result would be something like the duration and the rise time. So if we want just the rise time, then we'll take the result's rise time. We turn that into an integer. We run that into the C time, which converts that to local time. And then we can print it where we know where the flyover is. That should hopefully solve the problem. Alright, sounds good. So now we should have something that looks like this, minus the sparkles. So this will show the next 5 expected flyovers. I guess that's the end of our workshop. So this has been a short guide to how to get started with API requests in Python with the request library and a few other fun utilities. So from this point, you can probably start building a lot more complex things. If you want to go check out the Flask workshop, which I will bump back down in workshop pins, you can probably get to know how to interact with other APIs. Here are some examples of things that you might want to build in the future that also use REST APIs, but they're a little bit more complicated. So I have dropped some links for some workshops that you might be interested in that aren't ours. So thank you. All the Learn Month resources are in the Discord up to this point.